Hello. Thank you. Hey, hecklers already. Just you, Tiffany. That's all I got. Only you excited about seeing me. Hey, I want to thank everyone for coming. I think we have a pretty great night. I also want to thank our tech brand team, and as well as recruiting for helping set this up and arranging some of these great speakers we have. Shameless plug. Box recruiting team is in the back, free t-shirts if you apply for some of those roles back there. We got to pay for this food somehow and this alcohol, but feel free. You don't have to take the job, just take the t-shirt and pass in your resume. But no, boxes are pretty, as you can see, we have our new digs here. It's a pretty cool place to work. The culture is really good. They'll be serving dinner here in a little while, so that's included in part of the perks of working at Box, aside from the fun technology we work with. So tonight we're going to have a couple of presentations. Immediately following the presentation, there's a networking event out on the patio. So we have a patio outside here directly to the back, so you'll be able to mingle, talk shop, network, whatever you want to do. My name is Darren Alves. I'm the Vice President of Technical Operations here at Box. But without further ado, we're going to have two speakers tonight. The second speaker is Kyle Anderson. He's going to be presenting Yelp's PaaSTA, which is their platform as a service infrastructure. And leading the presentation is one of our own Boxers, principal site reliability engineer, Demetri Mouratis, and he's going to be presenting service discovery.
Thanks. You want your beer? No, later. Hi, everybody. Welcome to Box. It's my pleasure to welcome you to our new office and for our first SRE hour. So tonight I'm going to be talking about service discovery at Box. This is a topic that continually comes up for us, so it's something that we'd like to share with the community and share with the rest of you here tonight. By way of introduction, when you think about service discovery, let's talk about Box's infrastructure for a second first. We're primarily a PHP web app and JVM service architecture. We're mostly running on physical infrastructure. We're looking at working with IaaS and PaaS, which is what I think Darren was referring to with SmartStack, or OpenStack rather. We have currently kind of many approaches taken to trying to solve the service discovery problem. Some teams are using Zookeeper directly from like Scala services. We have HA proxy in a lot of our infrastructure. And we're using something in Puppet called exported resources, or what's called stored configs. That's the topic that I want to address. So if you think about service discovery, you can kind of think of it in two parts. The first part is what we call service registration. And service registration is a service saying, hey, I'm here, I'm this type of service, please come and talk to me. Service discovery is the second part of the equation, and service discovery is, hey, I'm a client, I want to talk to some service, and I want to know how to talk to it. So if you put those two things together, that's largely what we mean when we talk about service discovery. We're using HA proxy in a lot of our instances to manage service discovery today. And we have another piece of software called KeepAliveD, which acts as a way to manage what's called a VIP, or virtual IP address. That virtual IP address is something that would be configured from the client. So if you wanted to talk to, the backend foo service, your VIP might be backend foo123.yourcompany.com. So that's the client-side representation. When you think about it, you need to have high availability, because what happens if one of your machines goes down? So we introduce another layer on top of HA proxy called KeepAliveD, and KeepAliveD has this notion of a primary and a standby. So in the normal business case, right, the VIP would be living on the primary side, and that DNS entry or that IP address would be announced to the rest of the infrastructure, and you would connect in through that VIP, and you would connect to HA proxy, and then that would route you through to some backend service. That's pretty standard, pretty traditional stuff. And again, if there's a hardware event or some type of failover or other maintenance, now you use keep alive D to make sure that that VIP stays alive, and it floats the VIP from the primary over to the standby. So that's a pretty traditional and pretty typical way that we use HA proxy today. But this gets pretty complicated, right? Because we have a lot of services. And as you add more of these services, you start to have a lot of these mid-tier load balancers, and these mid-tier load balancers come in pairs, right? Because you need one for the primary, you need one for the backup. So as time goes on, and as you get to what's called the microservice architecture, you start to have a lot of these LBs shown here in the gray box in the middle. So the clients are talking to the LBs are talking to the servers, and this kind of design pattern proliferates. When we looked at this back in around November timetable, we realized we have about 124 of these virtual IPs or VIPs. Those are running across 203 HA proxy machines. One question in my mind is, why is that an odd number? And we use Nagios, as I'm sure a lot of you do, for the monitoring piece. And so when I went and counted, like, how many services does this result in inside of Nagios, it was 6,062 services, which is a lot. And another way to kind of measure the scope of this, is to look at the cost. And so I did a back of the envelope calculation and came out with $1 million of OpEx per year for just these Keep Alive D/HA proxy machines. So it's not insubstantial at this point, right? So let's talk about service discovery and how Box is solving it with Puppet. We're using a Nagios configuration tool called Noginator that actually predates Puppet. It's something that came from the CF Engine dates, if anyone can remember way back when. We're using that as a way to automate the configuration for the service discovery. So HA proxy configurations, for example, it can automate the adding of a new node into the load balancer. So you spin up a new machine, Puppet runs on it, it exports some resources, and now you have a new machine in your load balancer. The other place where we use service discovery via Puppet is with the Box Deployment Manager. The Deployment Manager is a piece of software that we also wrote in-house. This is how we deploy our services. So a service team might manage a fleet of 30 machines. They do releases on a schedule of 1 release per week. They use this Deployment Manager DM to deploy that code. So those are just some of the places where we're using Puppet for service discovery to help us kind of manage our infrastructure. As you look at this, it starts to get to be pretty complicated because we've got Puppet represented by that flask in the middle there, talking to an individual server, talking to Nagios, talking to the memcached instances, which we use to cache some of this data, and talking eventually to a MySQL database. So there's a lot of flow of data that all centers around Puppet, and that causes us to slow down sometimes because the Puppet runs do take some time to converge. So in researching stored configs or exported resources, I came across this documentation from the Puppet Labs folks. And they describe our situation to a T. And they say, if you're using the inventory service or exported resources, it's complex and impractical to use any of the older active record backends in a multi-master environment. You should definitely switch to PuppetDB. and point all of your Puppet masters at a shared Puppet DB instance. A reasonably robust Puppet DB server can handle many Puppet masters and many thousands of agent nodes. So we did not heed that advice, unfortunately, and we're in a situation where we have many Puppet masters, we have these exported resources, we have memcache, we have a database, and we have Nagios, all of this trying to cobble together a type of service discovery, service orchestration layer. So this has caused us some problems. If you think about it, Puppet for us runs out of cron on about a 30-minute schedule. So it can take 2 or more Puppet runs across disparate hosts for this config to converge. That's because one machine is responsible for sort of the service discovery and one machine is responsible for the service registration. And so if you add that up, you're talking about like an hour for this information to converge. HA proxy for us in a mid-tier environment is also a single point of failure. If you think about it, if that keep alive D that I demonstrated or showed earlier doesn't work, we can suffer a service outage. So if that VIP fails to fail over or disappears or something, that service is now down. The HA proxy machines we found can also represent a network bottleneck. We've had at least one incident where there was too much demand for bandwidth through an HA proxy machine and it saturated the network link. And that caused an outage for us. As I mentioned earlier, Puppet stored configs are not recommended for use in this fashion by Puppet Labs. So these are just some of the things that have caused us some growing pains with our current service discovery approach. So in researching all of these things, we came across a project called SmartStack. SmartStack is an open source service discovery software from Airbnb. And at least in terms of today, its use at Box is characterized as experimental. We have it running, but it's fairly well self-contained, and we're just kind of at the point now where we're investigating its use. If you think about SmartStack, it really comes down to 2 components. The first component is called Nerve, and that handles the service registration. Hey, I'm a service, please come and talk to me. And the second part is Synapse. And Synapse is, I want to talk to some service, where do I go to talk to it? They're both open source projects listed there on GitHub. Another fundamental piece of SmartStack is HA proxy, which, as I mentioned in the earlier parts of the presentation, we're already using at Box. So we're really familiar with HA proxy. And another component is Zookeeper. Zookeeper is an optional. There are other plugins that you can use in place of Zookeeper, like etcd. But we happen to already be using Zookeeper pretty widely at Box, and so it made sense for us to just continue investigating that. So those 4 pieces together, with the proviso that Zookeeper can be swapped out for something else, basically make up the SmartStack stack. As I said, HA proxy is already widely deployed at Box. It's reliable. It's been production hardened. It's proven. It provides great introspection and logging, and by that I mean it's easy to reason about what is HA proxy doing at any particular moment. The screenshot I have at the bottom here is a UI that you can use to investigate what's going on with HA proxy at any given moment, and its logging is robust. Its development team and community are pretty strong, so it's a really great component to build something like this on top of. Another component again is Zookeeper, and again we're already using this at Box. It's reliable, it's production hardened. Some of you may know AFER, Kyle Kingsbury, who did a bunch of these Call Me Maybe investigations. And he says, use Zookeeper. It's mature, it's well designed, it's battle tested. And he beats on all of these stores and NoSQL stores and stuff and finds the faults in them. So for him to say that means that this thing passed a pretty high bar. if you think about SmartStack, it's what's called a sidekick. A sidekick here means it runs alongside your service. So instead of making any changes as we may have done in the past to like our Scala nodes, to have them talk to Zookeeper or anything like that, you just simply run another daemon. It's a lightweight piece of software alongside your service. And in that way, you solve a lot of problems. For example, if you have multiple programming languages in your shop, which we do, you don't have to go and implement the client piece in each one of those programming languages. You can just use this sidekick approach and solve them kind of all in one go. It has other nice properties too, in that it's generating its own logs. The Nerve and Synapse pieces are written in Ruby, so they're easy to investigate if you want to see what's going on with the code itself. Again, they're both open source projects. So there's just a lot of nice properties in working with something that has a sidekick approach. Other companies out there have also taken a sidekick approach, including Netflix. I forget the name of their stack. It's like Carry On and Ribbon, but very, very similar to what, from a implementation standpoint, from a design standpoint, to what SmartStack offers. So this slide is kind of the crux of what goes on, so I'll spend some time on this one. If you think about the way that the service registration and discovery works, you start on the right-hand side of this diagram. We have a service we call our internal API, or colloquially int API. On that int API service, we would run the Nerve daemon. And Nerve probes or health checks that int API. By like hitting a URL, doing a curl, something along those lines, it can tell whether the int API is healthy, and it can use that information to publish that information into Zookeeper. Zookeeper is represented here at the bottom with the 5 green ZKs, and that's the way that state is shared between various machines in this environment. So it'd be something like, okay, Nerve runs, it looks at the int API. Is the int API healthy? Yes. Okay, publish that information into Zookeeper. On the other side of the diagram here, we have Synapse. And we have another machine type, we call it convert. So this is like if I uploaded the slide deck to Box and I wanted to get a thumbnail back out, we'd use our conversion service to do that. So the convert service is running Synapse, which is the other part of the stack, right? And it's subscribing to Zookeeper, looking for changes. Hey, where do I go to talk to the int API service? It takes that information out of Zookeeper and configures a local copy of HA proxy. So on the convert machine here, we're going to be running HA proxy. So what we've done, if you think about it, is take that mid-tier load balancer with the HA proxy configuration and Keep Alive D and pulled HA proxy out and moved it to the client. In this case, the client is our convert machine. So now the convert worker talks to localhost, and localhost is running an HA proxy machine, which is dynamically configured based on the information from Synapse that it gets from Zookeeper, that it gets from Nerve, to know, oh, if you want to talk to the int API, go talk to this IP number and this port. So that's the last part in the middle there that says connect. So now the HA proxy acts as the kind of, proxy, right, to let the convert machine talk through to the int API. And in this way, we've completed the service discovery problem. So this is very different from the way we traditionally solve this problem. And it has a lot of nice properties, like the time convergence for these things to come and go. So as new int API machines come into existence, Nerve can discover them really quickly, publish them to Zookeeper, and Synapse can pick up on that in a matter of seconds. On the flip side, if one of these int APIs goes down, the Nerve daemon detects that it went down, removes that information from Zookeeper, and then Synapse reconfigures to remove that down node from your HA proxy, and so therefore the convert machine doesn't talk to it anymore. So in either direction, up or down, the workflow happens really quickly. There's one other interesting element in Zookeeper here, which is they're called ephemeral nodes, which means like as soon as nerve dies, the nerve process dies, that data inside of Zookeeper gets automatically removed. So you prevent against kind of stale data. And that's just a functionality that's built into Zookeeper that's leveraged to help make this a more bulletproof approach for service discovery. So it's important to note that SmartStack is not a silver bullet. I've given you a lot of the advantages and comparisons to the way that we were doing things before, but let's not pretend that it solves all these problems and doesn't introduce any at all. Anytime you add new software, that comes with costs, right? You have more code, you have more bugs, you have more maintenance, you have more patching to do, and you have more complicated troubleshooting. So before, you could argue people are familiar with centralized load balancing, they know how to log in there to test how things are working. You've effectively taken that away from them and said, actually go to the local host and look from there to try to figure out what the service state is. So that's a little bit of a different workflow for our engineers, for anyone trying to deploy on this stack. And again, that introduces some costs. I would argue that it's actually nicer to deal with going forward, but it is undoubtedly a change, and that change itself has costs. So I mentioned before that choosing something like a sidekick approach means that you can be programming language agnostic. It works for us with Scala, we have PHP, we have Node. So being able to implement this once for all three of those in other languages is really nice. The sidekick implementation also means that you don't have to make any modification to your code. The services really don't know that they're talking through SmartStack at all. And being able to have that clear delineation between here's where my service ends and here's where service discovery begins is super helpful. It's reducing the complexity in our network. I showed you the 100 some odd servers that we were running HA proxy and KeepAliveD on before, and all of those can go away in this environment. So you get the same functionality, but you don't have this mid-tier load balancing anymore. And anytime you can remove infrastructure and keep your reliability up, that's always a good thing to look at. HA proxy can be configured to route around what are called network partitions. So for those of you familiar with the CAP theorem, you'll know that a network partition is one of the things that these types of systems have to be able to deal with, and HA proxy helps us with that solution. It eliminates the single point of failure that I mentioned before with regard to a misconfigured KeepAliveD VIP or a NIC that was overloaded with traffic. One other really interesting thing for Box is that this has the potential to make our environments more consistent. We frequently find that our dev environment is not quite exactly like our staging environment. Maybe the hardware was different, maybe we didn't have as much hardware, maybe it wasn't configured the same. If you use a tool like this and eliminate all that extra hardware, it makes it easier for you to replicate this scenario and have it identical across your environments. So let's talk about what's the current status. Let's see, in around October, November timeframe, we decided to start working on this, and my colleague Corey, who's here tonight, I think, and I kind of teamed up to get this going. So in just a few months, we were able to deploy on about 5 production Box services. I helped create the RPM packages for the SmartStack binaries, the configurations, and the dependencies. Everything's working great. Corey handled a lot of the Puppet work to deploy and manage SmartStack. It ties in really well with our existing HA proxy deployments. Since we were already using HA proxy like pretty widely throughout our environment, the ability to just work without having to rip that out was nice. We're using Wavefront for a lot of our monitoring, and this ties in really well with the Wavefront solution so that we can see graphs on how traffic is flowing through this, which helps again with the introspection that I mentioned earlier. And the SmartStack logs are also being consumed and shared via Splunk. Splunk we use for log analysis, and having a central place to be able to go in and troubleshoot what's going on, what's SmartStack doing at any given time is super helpful for us as well. So yeah, it's been a pretty awesome experiment for us so far, and we're looking forward to learning more about SmartStack. Here's some resources for you to review. I linked to a presentation where I first learned about this from AWS reInvent 2013. That's a talk from the original authors from Airbnb. And there's also 2 links here to Yelp's presentation, which is a nice segue into our next presenter. So it's my pleasure now to introduce Kyle Anderson, joining us from Yelp.
How about questions, Demetri?
Yeah, let's give it a few minutes for questions. That's fine.
Hi, very informative. Since you mentioned the CAP, my name's Oswald. Since you mentioned the CAP theorem, I'm guessing you focus on availability and consistency?
That's right, yeah.
Okay, the other question is, to what extent or not is Docker relevant for your infrastructure?
That's a great question. We have a team here at Box working on Docker full-time. They'll know more about it, but one of the things that I would say is that because of the sidekick approach, the SmartStack implementation is compatible with Docker, and I think Kyle will be able to speak to that a little bit more because they're similarly using both technologies at Yelp. Yeah, go ahead.
What was responsible for seeing that one of your API nodes was down and removing it from publishing that removal to Zookeeper?
Yeah. So the way that the down logic detection works is that Nerve is running on the same machine as that internal API, and it's periodically health checking that int API service, like running a curl command, running a HTTP GET against that service. And so it's responsible for verifying that that service is healthy at that particular moment, and then pushing that information into Zookeeper. And then the other use case or the other potential gotcha there is like, what happens if this machine just goes away completely? And the use of Zookeeper's ephemeral nodes means that as that machine goes away, it gets automatically removed from the configuration.
So how do you handle flapping in that case? Do you have a mechanism to prevent a node that's broken, coming up, registering, handling 30 seconds of requests, failing, and dropping out?
That's a good question. Flapping in general is a tough problem. We're not sufficiently far along in our investigation of this to see how SmartStack handles it. I know that Nerve is pretty configurable in terms of like what frequency do you want to check and how many consistent checks do you need to have in order to make a decision. That's very similar to the way like Nagios does it. But yeah, flapping is something we're going to probably have to learn more about going forward. Thank you.
I have one more question.
Sure. That's Harold. I recognize his voice.
So one of the benefits of having the central HA proxy built here is the debuggability that that interface provides, right? You can get a full picture of what your cluster is looking like. How much does Wavefront and Splunk or other SmartStack logging or interface kind of solve that problem? Because now you lose that, right? You no longer have that central picture on like, this is the big picture on what's going on. You know, how much have you lost in terms of that debuggability? Or in other words, how much does the replacement actually address some of those nice things that you're losing?
That's another good question. So to summarize, like by moving from a centralized configuration to a distributed configuration, you lose that sort of one-stop shop ability. I mentioned, and Harold repeated, that there's a few pieces of software that we're using to try to address that, like Wavefront for our metrics collection and like Splunk for our log aggregation. So I guess I would say it's a trade-off, and you get one level of indirection to get you the answer that you may have been able to get at one-stop shop before. But if you instrument everything correctly, you should be able to get the same aggregate information just from a slightly different location. So as opposed to going to a UI or as opposed to running a command against your centralized HA proxy machine, now you'll have to run a query against something like Wavefront and use that as a source of truth rather than just looking at each individual machine on its own. So net, I think it works out just fine. It just changes the approach a little bit, I think.
So HA proxy also has some load balancing features built into it, which I take it, so by having one, it has global knowledge of the load of all the things that's behind it. And you lose that with the way you're doing it. So I take it that you don't use it for load balancing. Is that?
Well, yeah, that's a good point. So his question and comment was, you can use HA proxy to do more than just proxy. You can use it to make intelligent decisions about where to send load. And you can measure latency, for example, and you can share that globally. I guess similar to Harold's question and my response there is like, you still have the ability to make that decision. You just make that decision 1,000 times as opposed to one time, and you get the same net result. Now, is there a case where you would do things differently because it was all consolidated? Yes, probably. So again, I'll just have to say we're not far enough along to have a really solid answer for that, but I take the point that you've given up the ability for one decision to be really high fidelity and really high probability of being right, and you've traded that off for many client-side decisions that can end up with different decisions. I could decide to use that machine, and you could decide that machine's too loaded for me. So I think in the end, we'll hope that it works out. Okay, let's bring up Kyle.
It's from me. I may have missed, but how's Nerve configured in the first place? Is it through the Box Deploy Manager? Is it through Puppet, by hand? How's that? How does Nerve know what to advertise?
I'm sorry, I didn't hear you that clearly.
Sure. How does Nerve know what to advertise in the first place?
Yeah, so we're using Puppet for that piece of the configuration. So we're dropping little stub files into Nerve to tell it, hey, you're this type of machine, you should look at this port and this protocol, and you should advertise with this name to this Zookeeper cluster. And similarly on the Synapse side, we're passing along that name to go into Zookeeper and pull that information back out. So Puppet's doing some of the legwork for us. It's pretty small. The configuration is actually very small. So it's been pretty manageable for us thus far and looks to be pretty extensible to where other teams who have looked at this, the early implementations that we came up with, are like, yeah, that makes sense. Okay, thanks very much, everybody.
Demetri, thanks.
Thanks, Derek.
So I think it was about 6 months ago, I was introduced to a gentleman named Sam Eaton from Yelp, and he was actually talking about their use of SmartStack as well as PaaSTA and what they had developed. And there were some pretty interesting concepts. I know I was pretty impressed as to what they were doing. And I think without further ado, I want to introduce Kyle Anderson, who's going to give us a little more detail around PaaSTA.
Hello, thank you. I'd like to present on what I'm calling the theory of passes. Yes, I don't really know how to pluralize passes. I don't know, whatever. Who am I? My name is Kyle. I work on the operations team at Yelp. I've been working on PaaSTA, the platform itself, for about 1.5 years. PaaSTA is Yelp's platform as a service. In case you didn't know what Yelp is, Yelp connects people with great local businesses. And marketing told me to put the slide on here, and I don't know, what does this mean? We have 32 push pins on our map. I don't know what it means anyway. Next, all right, so let's think about this. When companies sit down, they think to themselves, we got to solve some problems for the org, infrastructure teams get together, we've got a job to solve, and that job is getting software out to our users. And eventually, people end up building a platform. And even though maybe Box may not call it a platform, they have their Box Deployment Manager, and they've got service discovery, and they've got monitoring. It's a platform, so even if you don't call it that, let's just be honest with ourselves. We're all building platforms to get our software out there. I'd like to posit that we can think about these platforms in terms of what problems they solve. People get fixated on the particular technologies that they're based on. Lots of people love like single Go binaries, right? So it's like written in Go. It's like special somehow. You know how it goes. But let's focus just on what problems individual things solve, and maybe we can create a language or a holistic way to evaluate these things and see where they fit into the bigger picture. Is this actually theory? I don't know. I don't know if it's really a theory. But this one talk I was inspired by because I after I saw this talk on the working theory of monitoring, I was like, wow, this is a really good way to really analyze monitoring tools and understand them. So I thought I might just kind of copy it. Because there's a lot of stuff out there. So when you're evaluating technologies, it's easy to get overwhelmed. And if you don't have a good model for how to evaluate them and think about them, you might get kind of confused. Your PaaS goes here someplace. And then this is one of my favorite tweets is, I wonder how many organizations are saying that they're doing DevOps, but they're actually building some sort of bespoke PaaS. And how many of those realize it? Well, I'm happy to say that Yelp realized it, for better or for worse, and I hope everyone realizes it eventually. I think it's okay, just be honest with yourself about what you're doing, but maybe if you are honest with yourselves, you can save yourselves a bit of hassle. Just as overview, what I'm going to do is kind of present this theory, and then I'm going to talk about PaaSTA, Yelp's platform, and maybe with this theory, it'll be easier to understand what it does and where it fits in, just to give you a preview of the slides. So let's talk about how we might model a platform. If you can imagine, on the left, there's this configuration box. Somewhere you have to like configure the whole platform. And then in a kind of pipeline manner, you build something, some sort of runtime, an artifact, a Docker container, something. You deploy that thing. Then you use discovery or routing to find where that thing is and connect to it. And then in the last step, too often forgotten step, is monitoring. You have to figure out, is that thing you deployed up and is it healthy? If we break it down to these steps, maybe we can like analyze some of the software and see what the heck is going on. Let's talk a little bit about each piece configuration. I would like to note that this configuration is slightly and subtly different than control, although a lot of people mix them up. We think that we've got the CLI to like configure Heroku, but we're actually using it to control the platform as well. There's a subtle distinction between the two, and I'll talk about it a bit. But in general, most tools they've got an API, a CLI, a dashboard, some sort of configuration. Just keep this in mind. If I was being like really accurate with these analyses, we should probably split up the box, because Box the company may be using Puppet on the left-hand side to do configuration for certain things, like the Noginator, whatever. But like the other monitoring platform may not be configured with Puppet. Maybe they have a different dashboard for it. So maybe we need to split up that box. So as you're doing your own analysis, be honest with yourself about how that configuration box actually plugs into these things on the right. Containers, artifacts. This is AMIs, war files. Maybe there is no boundary between the artifact and the platform. Maybe you just rsync code around. Not that Yelp did that. Just rsync stuff. It's cool. Deployment. So when we deploy stuff, Box uses the Box Deploy Manager. Yelp uses Mesos nowadays. There's lots of deployment tools out there. This is somehow getting the code to the boxes in some sort of way. It's, maybe you just handpick the servers. They just called Intel B, so they get the Intel B software. Maybe they're called webs, and they get the web software. But some way you get this code onto the boxes. That's the deployment phase. Discovery and routing. You heard one discovery tool, SmartStack. There's many tools out there. It can be as simple as a handmade DNS pair with a load balancer, like an F5. It can be fancy automatic load balancers, like SmartStack. Maybe the tool just leaves us as the exercise to the reader. It's like, I deploy your software, but it's up to you to figure out where I put it. Monitoring, again, it's often forgotten. The reason this is most often forgotten is because it's hard to do. Like, it's easy to build some sort of like Docker deployment system and just say, well, monitoring, I don't know, PagerDuty, you guys figure it out. So they just kind of leave it off the block. But for a production platform as a service, you can't just forget about monitoring. So at Yelp, we're looking at these tools. How are we going to monitor this stuff? This is like really important. Before I go crazy analyzing all this stuff, I'd like to take an aside and talk a little bit about Yelp's architecture, and hopefully with that context, it'll make more sense of why we did what we did. Yelp started with Metal only in 2 different data centers. We started hearing about this whole like AWS stuff. We started investigating it, and then we found that it was pretty addicting, so we started using AWS for burst capacity because it's really cool. But then we realized, wow, this is getting really complicated. Now we're in hybrid. Now we've got like these AWS boxes, and we've got these Metal boxes. Luckily, we were using SmartStack to unify that whole story, but it gets complicated pretty fast, especially when you talk about deployment. Just some screenshots. We've got East Coast. We're in the standard AWS regions. There's nothing really special about that. The special thing, though, is we have data centers close by, and sometimes we consider them a whole unit because it's convenient to have burst capacity. Okay. But as soon as you're talking about multi-AZs, multi-region, multi-data center, Metal, AWS, How do you describe what services go where and who talks to what, and then monitoring the whole thing, it gets pretty complicated. So whatever software we're going to use needs to be able to kind of tackle this. We're not just running one data center. We've got stage, we've got dev, we've got all these things. So a simple deployment system kind of isn't going to cut it. Let's look at some tech. Let's apply it to the model and see how it fits. So Heroku. Raise your hand if you've used Heroku before. Fewer than, that's okay. Heroku is a cool platform as a service. It's not open source, but it's kind of fun to use because you just run git push Heroku and it ends up there and they take care of the rest. It comes at a cost though. That simplicity comes with a lack of some limitations. People swear by the 12-factor app manifesto, which is if you were to retitle it, you might title it as Heroku's platform limitations, but it doesn't sound as sexy, so we just call it the 2-factor app manifesto and make it look like it's like a thing. But in practice, there's severe limitations to Heroku's platform. You can't deploy to your own metal boxes. It's there's things. Heroku's so cool though. I still love it. Yeah, but and monitoring there's like add-ons and stuff, and a lot of these is pretty hands-off. But let's move forward. Amazon ECS, pretty popular thing nowadays. It's like, oh, Amazon can run your Docker containers. But you can see there's a couple boxes that are kind of empty here because it's only half the story. If you just launch a bunch of EC2 instances and then ECS launches Docker images on them, and now they're running, but you need probably an EOB to communicate them, or now you need SNS to handle message passing. You need a lot more things, and Cloud Health for monitoring, and it's AWS only, of course. But it's important to really understand where Amazon ECS really fits in with this whole Docker thing. And when you look at Beanstalk, it's a little more full-featured in terms of like a PaaS. So Beanstalk can take any kind of code, launch an ASG, configure a load balancer for discovery, get you monitoring, and has a great configuration control plane for you to use. It's like a full PaaS. So it's cool. AWS only, so keep that in mind. And also, it's kind of not really good at like doing the whole multi-region thing, which is one of Yelp's requirements. Dev prod stage, I don't know, man. You got to have like multiple accounts. I don't know what to do. Nomad, new kid on the block. It uses Docker containers. Nomad, of course, is the actual scheduler. No big surprise. They recommend using their other product console for service discovery. Monitoring is just kind of left as an exercise to the reader. It's open source. You can run it on your hardware. That's cool. I hope you're getting the pattern. I think this is a pretty decent way to think about these kind of tools and where they fit in the whole architecture. And of course, Docker Swarm. Docker Swarm, man, it runs Docker containers. It's cool, but it's not the whole picture. You still need your own tooling on top to coordinate them, or if you're going to do Docker links, or however you're going to do that, you have to figure that out. So if you're going to build a platform on Docker Swarm, just be aware of what pieces you need to fill in the gaps with. Tudum is something that they bought recently. It's more full-fledged PaaS, still kind of beta. Kubernetes, didn't realize I had so many of these. Docker containers, replication controllers, blah, blah, blah. I hope you get the picture. There's lots of ways to analyze this software, and I think this model is a decent way to think about it. I guess at Box's platform, I don't know, just threw this out there. We now know that the custom box is actually the Box Deployment Manager, SmartStack, as well as other things, centralized load balancers, Nagios, and then Puppet, and then the other monitoring platform. Anyway, so fill in the blanks for your own corporation here. Hopefully you can, and hopefully it makes sense. Okay, so we talked about this theory, what I'm just coming up with is just kind of BSing. So what is PaaSTA? Well, PaaSTA is Yelp's platform that we built to help solve these problems, to help unify these things and kind of consolidate the different ways that we deploy things at Yelp. As an infrastructure team and being a member of the infrastructure team, I see it as my job to help bring value to the org, whatever that means, by building tools that solve problems for mass, lots of teams at once. Platforms do this, and that's why I think they're so cool. It is opinionated. On our docs page, it is open source. You can see the opinions that went into it. Of course, they're Yelp opinions, or more specifically, they're our opinions of company employees that work at Yelp. They may not apply to your infrastructure, but you should just be aware of how we built it and why we built it that way. I encourage you all to, as you're building things, to be aware of the opinions that are going into that software. Not all software is opinionated, though. SmartStack is a good example of a piece of software that is totally unopinionated. It doesn't care that you're using Docker containers or Puppet or what. It just takes a config file and announces and then configures HA proxy. You can make it do other things, but it doesn't know anything about your platform. You configure it, if that makes any sense, as opposed to other more vendor-specific tools. What is PaaSTA made of? Well, we use Docker containers for better or for worse. We use Marathon and Mesos for scheduling execution. I'm pimping my cool Mesos sweater, which is great. We use SmartStack for service discovery. I'm such a big fan of SmartStack. I wish I could have a whole presentation on SmartStack. I'm such a big fanboy. Talk to me afterwards if you want to talk more SmartStack. Just love it. And we use Sensu for monitoring. Sensu is a modern monitoring framework. It's not like Nagios where you have to let it know beforehand what you're going to be monitoring. You can just send it events. It's pretty great. If you're not aware of what Mesos and Marathon are, here's some quick analogies. If you have a Linux host, if you're going to host, Linux hosts are to data centers as the Linux kernel is to Mesos. So Mesos is in charge of resource allocation, just like the kernel is in charge of memory allocation. It's aware of all the resources that are out there in the pool, so it knows where there's free resources where, CPUs, that kind of thing. Upstart on a box or systemd or supervisor D, something like that, is like Marathon. It takes something and it keeps it running. If it dies, it launches it again. A process on a box is kind of analogous to a Mesos task, which in the end is a Docker container for us. SmartStack. So we use SmartStack at Yelp, and because SmartStack is kind of so unopinionated, it gives room for really some interesting things. For reference, I've got the model up there. This is the discovery and routing layer. Because we're in multiple data centers and multiple AZs and multiple regions, we can configure SmartStack to selectively advertise where we want services to be advertised. I'll show you some more pictures to help explain that. The way we configure Nerve is we just inspect the local slave. I have a saying that the only IP you can trust is localhost. The only IP we trust here is localhost. We don't depend on some sort of centralized scheduler to tell us what is supposed to be running in the box. We already know. We can just ask the Mesos slave what it's running. It's running on localhost, and we can advertise those services. Because if the Mesos slave thinks they're running, then we should probably be advertising. Now, whether they're healthy or not, we'll let HA proxy and Nerve figure that out. But at least we'll advertise them. One cool trick is we use this Yocos thing. You can Google for it. It allows us to run one Nerve and one Synapse on each box, and that's it. The Docker containers still communicate with it just as is. We don't have to run SmartStack in Docker, which would suck. Configuration. I wanted to have a whole couple slides on this because I think it's such a big deal. Because without pre-thought about how you're going to be configuring this behemoth of a platform, you can get lost. How do you want your developers and your admins and your operators to actually interact with this PaaS? Well, ask yourself that question. How do you want it to work? Well, if you're designing it, you can just pick. Do you want a REST API that you want your clients to do? Do you want a command line tool? Well, at Yelp, we really like declarative control. This is analogous to Puppet, where you define, package ensure latest versus just apt get install Apache, say. We like the ability to declare what we want to be running where and let PaaSTA make it happen, as opposed to Heroku deploy and prod. So we decided for PaaSTA, we want Git repo. We want a Git repo and we want configs. That's all we want. So we make the automation and make it happen. And I'll show you some examples. That doesn't mean we don't have a command line tool to be the control. So if you need to stop, start, restart, scale, whatever, not scale, but we use the configs for the configuration. Let me show you some examples. Let's kind of touch on this. They're declarative. We use Git for rollbacks, audits, access control, blah, blah, blah. YAML files. It's really powerful to have all these YAML files in one Git repo because for any new person who's never seen the platform, for anybody who's thinking about deploying their own service, they can just look at all the other YAMLs and see what's out there. This is very different than other platforms where it's not very obvious. So just being able to kind of inspect all the services at once is pretty powerful. Easy to distribution. Databases kind of suck. Dev prod splits, whatever. This is one Git repo we can sync everywhere. Here's some examples of some SOA configs that I just kind of made up. We have specs for these. We have syntaxes, syntax checking and whatever. but they're really freeform and they're very generic. The reason they're very generic is because they're meant to apply to to the service as a whole, but to multiple applications. So multiple applications utilize these shared centralized SOA configs for a lot of gain. It means that you can kind of declare in human readable format in one place about the things about a service and let all of the other tooling inspect that shared location. Now, to be clear, this is not the configuration for a service. So this isn't like API keys or feature toggles. No, no, no. This is about the service. What team owns it? Where is it deployed? How much RAM does it need in the PaaS's case? If you can believe it, these SOA configs we built predate PaaSTA itself. We just thought that SOA configs were such a great idea that we wanted to bake it in as part of those opinions into PaaSTA. One of these YAMLs is SmartStack, and we'll show that. This is just a snapshot of what it looks like when you make a platform as a service tool that's so cohesive that it can understand all of those different aspects, those, the deployment, the monitoring, the service discovery, into one tool that knows where all the pieces are. Now, you can run PaaSTA status on the engineering blog, which is just our blog dot whatever, on 2 of our prod clusters, and you can see that all this data is now in a place where we can get at it. We can inspect the Git SHA from the deployment mechanism. We can inspect what the user thinks it should be doing, running, stop, whatever. We can inspect the deployment system. We can inspect the monitoring system. We can inspect the service discovery mechanism. This is super, super great. Without a tool like this, it not only makes it just more burdensome for operators, but also developers. Developers want to have fun using their tools. They want to have an enjoyable experience. And having a cohesive tool like this makes it that much more enjoyable. So this is just one screen. I'll show you more. So how does PaaSTA fit in this model, this theory model of platforms? Well, on the left-hand side, SOA configs are how we configure everything about PaaSTA. We have a config file for the deployment. We have a config file for the discovery. We have a config file for the monitoring, all those things. And they're called exactly what you might think. It's monitoring.yaml, it's smartstack.yaml, et cetera. Docker containers are the building block. I'm holding out for Rocket, I think, or AppC. I don't like Docker very much. We can edit that out of the recording, I presume. Just kidding. Mesa's Marathon do the scheduling, SmartStack for the discovery, blah, blah, blah. That'll all we talked about. So this is how PaaSTA fits in the model. Obviously, it's fully fledged out. This is a production platform as a service that we run in real life at Yelp, so it's got all the pieces filled in. I don't show this to, like, you might think that I'm trying to pimp my own platform, or that I'm trying to sell you PaaSTA, or that I'm trying to make you feel bad about your own platform. I'm not. What I'm trying to do is show you what it could be if you take all the pieces and you build a cohesive set of tooling around them. We did. We didn't reinvent the wheel here. We're using Mesos, we're using SmartStack, we're using Sensu, using Docker. We just put the pieces together and wrap them all together in a cohesive way. And then on the left-hand side, we gave developers a consistent way to configure them, the SOA config directory. So that's cool. You got some tech. You put together in some cool pieces. But here's where I'm going to go out on a limb and make a kind of far out there proposition. Unfortunately, Verifies wasn't highlighted, but here's my proposition. When we're building these tools, the discovery and routing configuration should imply how we deploy. Yeah? Okay. And then deployment, its job is to attempt to meet what we asked discovery to be. Okay, with me so far? I'll show you more pictures. Monitoring's job is to verify that our deployment and discovery requests have been met. So if we've asked to be discovered in a particular location, monitoring better verify that we're up in that location. If we've been asked to deploy in all of US West 1, monitoring's job is to make sure that happened. So what does this look like in real life? This is an example of our SmartStack YAML. It's got a lot of pieces that are optional, but I'm using them to kind of show you what it might look like when you have a really kind of fancy SmartStack configuration. Check out the advertise and discover settings. This service author has declared that they want their service to be announced at the region level. So this whole SmartStack thing you've been hearing about, it just has this nerve daemon that registers in the Zookeeper. you can control how widespread that net goes. If you want it to only register in a section that's only encompasses the local rack, maybe, or the local availability zone, or the local region, or maybe the whole super region encompassing both Metal and AWS, we allow authors to declare that, which is pretty awesome. So here, this particular service example, we're discovering at the region level, like the AWS region level. You can see we've got some extra advertise here, just as an example of one thing we can do with SmartStack, where you can just announce in another nerve far away. So if this service author can't deploy in US West 2 for some reason, or either just lazy or just we don't have the resources, you can deploy in one place. We can configure our service discovery mechanism to advertise over there as well. That allows us to kind of, I don't know, just expand the scope of a particular service. And it's an HTTP service, it's got a health checkpoint, whatever. Okay, so how does SmartStack and PaaSTA interact? How does this fit into my proposition that the discovery needs to be informing the monitoring? Well, let's look at a concrete example. Let's say that we've got two regions. One may be in Metal, like we have a data center with a couple cages. And then we have a region in AWS called US West 1. It's got a couple AZs. You know, they've all got their spheres of influence. How are we going to configure SmartStack here? Well, we leave it up to the authors. If the service authors thinks, well, my service is totally latency insensitive. It doesn't matter where you put this thing. Just as long as it runs somewhere, I don't care. Metal, AWS, whatever. This is really great for operations because we can just, wherever we've got capacity, we'll fit them, which is super, super great. So let's say in this example, they've asked for 6 tasks, and they're either not using SmartStack for whatever reason, or they've set their discovery to be super regions. So they've informed the deployment system that the entire super region should be treated as a whole. When these instances announce themselves in Nerve, they'll announce themselves in the entire super region. Metal, AWS, all mixed together. Well, our deployment mechanism can take that hint and say, well, if you don't care, then I'm just going to launch you wherever I've got capacity. So in this case, it does. It launched 4 on Metal or whatever, and 2 in region 2, and 1 of the crazy AZs. Because they didn't ask for anything special, so they should all be treated pretty much equally. And if we've got capacity, let's do it. Cool story, we're starting to use Spot Fleet for our PaaSTA boxes, so we're saving buku dollars on those instances, and it's great. Okay, so let's say that the service author said, wait, my service is a little more latency sensitive than that. I really only want to be talking to my local region stuff. So anybody who's in region 1, I only want them talking to the instances in region 1. I don't want them going across to AWS to contact anybody. No problem. We just say region discover, and now again, in my theory, I posit that the deployment system needs to be picking up on this. What we do. Our deployment system says, oh, you want to be discovered at the region level? Well, I better make sure to deploy you equally in both regions, or how many regions we have. Otherwise, you won't be able to be discovered in that remote region. Seems to make sense, right? So in this case, there's 6, so we just divide. If we detect that there's 2 regions, we just divide by 2, and we put equal number of measures in both. In Marathon, this comes out as a constraint language declaration for region, group by, whatever. The point is, we're using our service discovery mechanism to inform the monitoring about how it needs to do its job. Let's look at another region. Let's say that they wanted to be discovered only in the local AZ. So we do this for like Memcache or MySQL, where the latency just kills. And we're doing so many back and forths that there's no way we want to be talking across even AZs. Again, no problem. We can just say our advertise and discover is at the AZ level, habitat, whatever. And then Marathon will inform Marathon, hey, you better allocate them 1 per, or evenly amongst all of the habitats. So it does. We say there's 6, and there's 6, and there's a spot on each. So far, so good. We're using all of this data in the shared central repository. We can inspect, and we can use that intelligence to really awesomely configure our deployment system. But what about monitoring? I mentioned monitoring is kind of one of those things that we forget, right? Well, remember what I posit monitoring's job is? To verify the discovery settings, or to verify the deployment settings. Well, let's say that the author has asked to be discovered at the habitat level or the AZ level, each one of these pink boxes, pink ovals. But they're not in one of them. How do we know? Well, we know you want to be advertised at the AZ level. let me just enumerate all the AZs, and let me just look in each one, and are you up? And what's your replication? Well, in this case, we're going to look in through each one. We're going to find that you're not in this AZ. We better alert, because this means that any customer of yours in habitat F can't find you. Like, you're basically down in that habitat. We need to let the author know, because this means that maybe we're out of capacity in that AZ and you need to change your mind about what you need to be doing. Maybe you need to add an extra advertise to get in there. Maybe you need to relax your latency constraint because we just don't have enough boxes, something like that. Heck, maybe you're down in there for other reasons. Maybe you depend on something that's in there that, I don't know, EBS, it's Amazon, man, who knows? This is what it looks like when you run the status command and we can't meet that contract that you asked it. In this particular case, it looks like this demo service is asked to advertise on each AZ, and for whatever reason, we've asked for 6, and so our deployment mechanism is going to say, well, I better divide into equally, because otherwise one will be unbalanced or we won't have enough in each. But for some reason, US East 1A is down, so we can't launch anything in there. So Mesos can't launch any tasks in that AZ, so you're down. But the way we know you're down in that AZ is we know that we need to check each AZ, we can inspect, and we can just query HA proxy, because it knows. It has the backends that are up, the backends that are down. We just divide. It's pretty great. So to recap, discovery and routing should be hinting at your discovery system, your deployment system, about what it needs to be doing. The deployment system tries to meet that contract. So if you've asked to be in every AZ, we better make sure that you're in every AZ. And then monitoring is there to let the author know that we can't meet that contract for whatever reason. Maybe your service is crashing over in AWS, maybe AWS is just down, who knows. The important part is we need to let you know, because we can't meet what you asked. You asked to be available in every AZ, you're not available in every AZ, you gotta do something. So, that was a brief overview of my crazy theory of monitoring. I think it's pretty good. And that was how PaaSTA fits in. It's pretty far out there, and I didn't spend that much time on explaining what PaaSTA is per se, but I hope you got a good impression of what it is through just me rambling. If you're interested in PaaSTA itself and how it works, or the design principles, or any of the videos, or any of the technologies that back it, here are some links. And that's it. Thank you. Okay, ready for questions, and microphone passing. Go ahead.
All right, great presentation. 2 quick questions. Do you have a dashboard where you can see everything at a glance?
No. We basically depend on the dashboards that come with the software. So we use Marathon for deployment, so we use the Marathon dashboard. Mesos has a dashboard, Sensu has a dashboard. We just use all the dashboards. We use that status command to help authors kind of aggregate. We could probably make a dashboard, but I like the status command because it's specific to your service. You know, the authors don't want to see, like, it's just slightly more, I don't know, it's something.
And you look at so many different facets of your infrastructure. Do you ever fall into the trap of analysis paralysis, or are you just that good?
Analysis paralysis.
You're looking at so many different things you can't decide because there's just an hyperabundance of options.
No, and it's not because we're good, it's because we're, I guess you could say we're good. We're just, I'm thoughtful. I just like to think about this stuff. Most of this analysis is actually retroactive. I have other presentations where I explain our reasoning behind picking the particular technologies. But like most things in operations, things are kind of organic. You know, I deployed Sensu during a hackathon and people liked it, so we built it. We picked Mesos because it was battle tested and has an upgrade path, unlike other deployment mechanisms that don't. Marathon was a natural choice because it's a simple API, and SmartStack because we came to the same conclusions that Box did about sane, fast, good discovery mechanisms. So, next question.
You just wanted me to walk all the way over here, didn't you?
Can you describe a little bit more on Sensu and how you're using it with PaaSTA? Specifically, I'm curious, when someone gets an alert, is it sort of a passive alert where they get it, but the customer experience is down until someone resolves something? Or is there sort of an an active monitoring at the HA proxy layer where traffic isn't even passed to that particular node when that's down, or some other sort of safety mechanism in regards to that?
It would be a little too hard for us to really tell if a customer is impacted. We don't bother with that. We leave it up to the author to declare how important the service is, whether it's page worthy, should it just make a ticket, should it just show up in IRC if it's down, and which ones. If prod needs a page, or does it dev C? If it's in dev, does it need a page? We leave it up to them to decide all those knobs. But for the most part, PaaSTA just monitors deployment and their replication, their HA proxy. So you could call it active in your verbiage. It's actively monitoring HA proxy once a minute, inspecting the replication, and then just if it's down, it's down. If it's up, it's up. This same code path for the check is this. This is literally the same. So when you get the alert, this is what you get. It's the same code path. Kind of cool. Does that answer your question?
Yeah, I think so.
I wish on other presentations I have a whole slide pimping Sensu, because it's another technology I think is totally underrated and super cool. If you're going to be doing some fancy deployment mechanism like this, where services come and go, and now they're deployed on prod and now they're not, oh, here's a new service, like Nagios can't cut that. Like, you need a tool that doesn't need to be pre-configured about a service before it can start acting on it. And Sensu is one of those tools.
So Yelp is an old company by Silicon Valley standards. Can you speak a little bit about the culture that allowed you guys to have a modern stack in an old company?
It is an old company, relatively old. The culture comes from empowerment. It comes from management is one of those, the culture comes from just management saying, we have this problem, you guys are the professionals, build it. Or buy it, or you let us know. It's kind of refreshing. I've worked at other companies where it's really not that case. It's top down or whatever. But my best answer to that question is that it's kind of bottom up. Management depends on the engineers to be able to come up with what solutions they think are going to work best in our environment, and I'm happy to work there because of that. The age, I dare say age is irrelevant. It's probably not irrelevant, but it's a small factor. You can be an old company and have good culture, or a new company and have good culture, or toxic culture. I think age is probably a red herring.
How does PaaSTA tie in with your pre-production environments and the different kind of stops you go along the way to get to production? Do you have different configurations for different environments, or is it one that's kind of translated somehow? Can you explain a little bit about how that works?
It's all the same. As you can see in this demo, we're analyzing a cluster in Nova Dev C, which is Northern Virginia Dev C, just dev. Our pre-production environments, our stages, our devs, they're all PaaSTA. Now they're distinct clusters, so they're completely isolated, but they're still PaaSTA. So that's all the same. Sorry, can you say? I can't hear you.
Is there one configuration per service?
Remember that in SOA configs, the service has all of the things. So there's one folder per service, you might say. But that doesn't mean that you can change the configuration on a per environment basis. For example, in the Marathon YAML, you might say that in prod it needs to be like this, and in other situations it's different. So in stage, don't page, whatever. This monitoring YAML here, this example, just sets like the global defaults for a service, but you can change that, if you need to drill down. So we give developers the knobs to change the configuration if they want. So yeah. Keep in mind, though, that remember, these are like meta configurations about the service. For actual service configuration itself, I don't think this is your question, just to confirm, though, like if a service says that in prod they need to be using like MySQL, but in dev they need to use SQLite or something like that, that's not here. That's your app, your own configs. It's not these configs. So I hope that answers your question about pre-production environments.
Yeah. It kind of answers it part way. It just needs some confirmation. So the distinction I'm looking for is like in production you may deploy X number of nodes, like 10 nodes across multiple regions, but in your one stage in pre-prod, you just want one node for particular type of testing. Like, where are those definitions?
Yeah, they're in here. That's I don't have a good example on just a screenshot, but there's a file for each. So you just say that. For the most part, though, our default like template, it's just all symlinks. So all dev, prod, stage, they all just point to like one file. So we start you off with just everything's all the same. But in practice, it's kind of wasteful because in prod, you may need you may need 100 copies of your service to serve, I don't know, photos or something. But in dev, you only need like 3. So it's kind of wasteful to literally duplicate prod to that degree. But to me, it's more important about the code and not as much as the instance count, if that makes any sense. So I'm not personally worried about a mismatch between prod and dev at this level. I'm more concerned about code being mismatched and application configuration, which is not really here, if that makes any sense. One of the nice things about building an opinionated platform for your company is that you can enforce these principles at the platform level. For example, with the code thing, if you're on PaaSTA, you're automatically in a Jenkins pipeline, which is one of these is deploy YAML. We just build a Jenkins pipeline for you. So you kind of can't not have synchronized Git versions across the org as you go to prod. That doesn't mean we don't let people like have a stopping point or a canary or whatever, but in general, it comes kind of pre-populated with the opinion of your code should be the same across as you flow from dev to prod, et cetera.
So I have a question about actually the app configuration. Do you bake them into your Docker containers and have like Docker prod, Docker dev, Docker canary, or do you have central configuration services, something like that?
Yeah, that's a good question. That's a good technical question about the actual like nuts and bolts of this stuff. No. One of the this is like a kind of a core tenet of most application development systems is that the artifact itself should be immutable and the same everywhere. So you don't want to be building a dev version and a prod version that goes back to the desyncing problem. So anything that's environment specific needs to be pulled out. Where do you put it? Well, at Yelp, Yelp, we're not bound by 12-factor app limitations, so we have, surprise, config files. So we just let developers have a config file for the service, and if they need to change it, they change it. We mimic Hiera, so if anybody's ever used Hiera and Puppet, it's pretty freaking cool. It allows you to like hierarchically define configurations, so you can set defaults at the top, and get more specific as you go down, because service author might have a different say. In prod, it may not be so. Sure, you can say in dev it needs to be one way and prod another way, but what if it's in US East it needs to be one way and US West it needs to be a different way? What about US East 1A it needs to be one way and US East 1, So Hiera allows you to kind of describe that in a really succinct way. Anyway, so that's a description of
For a question quick. So how do you orchestrate deploys then when, let's say, you have a new version and you want to deploy that new version to, let's say, production? Like, how do you make sure that the config and the deployment arrives at the same time?
Yeah, so that's one of those things that when you ask that question, it implies that they should be, that they need to be. And at Yelp, we don't believe they need to be. At Yelp, we believe that if you're going to deploy a config, it needs to be backwards compatible with the version that's on there now and the new version. So if you're going to make some sort of breaking thing, you just can't. You can't make a breaking change that's going to that a config push is going to that's going to break an old or new version. So that's how we kind of brush that problem away. Is we say you just can't synchronously deploy configuration and code at the same time reliably without baking. But if you're going to bake, it takes away the power of being able to deploy configs freely. So in practice, it comes down to just a folder that we sync around, rsync, and Docker just bind mounts it. Kind of no big deal. But it comes at a cost, and that cost is developers need to be aware that their configs can change on real live running code, and if you need to pick that up, you need to write some code to pick that up, or if you're going to just, you can not do that, and you just ask for a restart. So that's another way you can tackle this problem, is just do a code change, a config change, program your app to not pick up new configs, for better or for worse, and then tell the whole thing to restart. Different way to do it. Heroku does that.
So Darren, I have a question. On PaaSTA, do you guys support SDN? So when you're in your hybrid model and you have multiple regions, are you configuring GRE tunnels, or are you relying on, say, VPCs and VPNs that are already created across those infrastructures?
Yeah. No. So I guess I don't have a really good diagram, but we use Amazon's Direct Connect feature to be able to make it look like the Amazon region is really close and really fast and 10 gig all the way, and it's great. But SDN, I mean, it's not really SDN, it's just, that's just the network topology. SmartStack and this kind of SmartStack flexibility, the ability to say, hey, I need to be at the region level, I need to be at the whatever level, I need to be at the super region level. Although it kind of looks like an SDN, it's not. It's really just you're connecting to an HTTP proxy, and HTTP proxy is routing you to the right place. It behaves like an SDN maybe, but it's really not. So in practice, it's for the most part it's all flat. It's just one big network. It's it's all prod, and we depend on SmartStack to be able to get us to the right place and give the kind of illusion that you're tunneled to the right production instance that you should be talking to. Now, again, that may be in a region far away. Maybe that region far away is cross-announcing into your local data center for you to use. But again, it just gives the illusion that you're getting there via the SmartStack HA proxy, which is kind of like far out there because SmartStack itself is, I mean, you guys are going to go home, you have to sleep on it. Like SmartStack itself is kind of mind-blowing. It's kind of hard to get your head around it if you've never encountered that kind of like localhost-centric, local client-side load balancing paradigm.
You have so many things going on and a lot of things can go wrong. It seems like that would be sort of orthogonal to creating a self-healing system. I'd just like to know your thoughts on that.
Yeah. Yes, that comes from, there's two aspects of that question is first, lots of things can go wrong. Certainly lots of things can go wrong anyway. Lots of things can go wrong with keep alive. I guess not many things, whatever. Things can go wrong. So the most important thing I would say to that is just tooling. So having the tools, having the logs, instrumenting everything it's kind of a no-brainer, but it's unless you invest in it, it won't work. So one of the tools I didn't screenshot is PaaSTA Metastatus, which is it's a query, it's equivalent to status, but about the whole cluster. How's Zookeeper? How's Mesos? How's SmartStack? How's Marathon? How's Kronos? Sensu? All of the things to help not just developers say, hey, is it my service or is the whole cluster having an issue? But also operators. Operators can run metastatus-v and see and really drill down and see what's going on here? Is it a whole group of slaves? Is it an AZ? So having good tooling helps with that. But on the side effect, that whole self-healing thing, that comes from good architecture and good components. So an example of that are things like Mesos, which is battle-tested, distributed, no single point of failure, Paxos, yada, yada, yada. Zookeeper, same thing, Zookeeper's battle-tested, really, really strong. Marathon is getting there. It's also HA, no single point of failure. Yeah, so picking really good components can help a lot with that self-healing. And again, man, we didn't write this stuff. We just use it. I know it sounds like it's PaaSTA, whatever, but remember, we're just using these existing open source components, and they're really good. We can stand on the shoulders of giants by taking advantage of the existing engineering effort that went into Mesos, SmartStack, Zookeeper, et cetera. Dashboards can also help, he said, with that whole situational awareness. It's true. Maybe someday maybe we'll get an intern to make a cool dashboard.
So I think we have 3 more questions, and then we'll just close out and go outside.
This is actually related to SDN. Maybe this is the answer: is you have really good tooling, but how do you deal with network ACLs and stuff like that in terms of how to talk to everything, making sure that you're doing security, as you're adding all these ephemeral nodes, different groups, different services, who can talk to what. Is that all factored in, or is there a separate service for all that?
To be honest, we don't factor that in, and for the most part, we trust the foundation infrastructure. So we trust that the VPCs are secure, we trust that Puppet has securely bootstrapped it, et cetera. We trust that the network is partitioned correctly. We don't bake in ACLs at this layer. Some of our more sensitive services do have secrets, and they do have sensitive control points, but we push that back on them. So when they they do their own SSL client verification, whatever you call it. but we push it all the way to the application to avoid baking it into the infrastructure. I don't know, because we're lazy? Maybe.
Yeah.
Does that answer your question?
Yeah, I think so. I think.
It's not very satisfactory. It's not very
Yeah, I guess so. It sounds like your environments are sort of pre-provisioned, and this is sort of deploying on your existing capacity, and you're relying on whoever's initially provisioning your capacity to set up that all correctly.
Yeah, I mean, me. I'm the one doing it.
I see.
Yeah, I trust me. But no, yes, the ops team is in charge of provisioning. So, yep, same team.
So my question's about your zookeeper topology. So do you have individual clusters in each one of the Amazon regions and your bare metal regions? And do you have one that talks to all of them? How does that look?
Yeah, it's a good question. Zookeeper is really good, but it works best when the nodes itself are close and very solid. So to accomplish that, in most cases, we deploy the Zookeeper ensemble in data center, and only one for the entire super region. So this entire thing would be using one Zookeeper cluster. The way we mimic the whole like multi-tier advertise and discover thing is just through different folders. So we just advertise in different folders. So even though something in, say, Habitat E may be advertising locally to Habitat E, it's still connecting to the rock-solid, metal-based, one in each rack Zookeepers back in the data center, just under the Habitat E folder, if that makes any sense. Fewer Zookeepers are good. You know, in general, you want to minimize the number, like the sheer sprawl of your infrastructure. Zookeeper is one of those things that if you can get away with one really good rock-solid cluster instead of a bunch of clusters that may not have as many nodes to them or maybe on hardware that you don't trust, this has worked out for well, just kind of for us anecdotally. So we have one cluster per super region. Super region we define as about 5 milliseconds. Contains that's AWS and Metal locally via the direct connect, so they're kind of close. So one set of Zookeepers per one of those. But in practice, we only have, I don't know, dozen super regions. It's not that many, but it's as few as we can get away with. I would not recommend having a Zookeeper ensemble going any wider than this scope.
So does that mean that you're limited to service discovery within that super region?
Nope. Remember my example where we have the, I know it's hard to keep track of like all of these cool features. Like here's an example where a service has declared that they want to be only in, I don't know, wherever they're in, but they need to be extra advertising to another remote region. In this case, US West 2 prod. Again, the Zookeepers are still there. It just means that the local nerve is connecting to them across a zone, but the Zookeeper ensemble is still tightly packed in US West 2.
Thanks a lot, Box, for having folks over. I've been walking past this building as it's being built for a zillion times, and it's super nice to see it finally start up. I asked the organizers, please, can I make a short announcement at the end? And so I work for the Internet Archive. So we're a charity, and we archive the internet, among other things. And we're actually looking for an operations manager to start a new data center for us. So please talk to me afterwards if you're interested.
Kyle, thanks a lot.
Thank you.
So I want to again thank the tech brand team at Box and the recruiting team for putting this together. Kyle, Demetri, I'm hoping you guys are going to hang around and talk to folks if you can for the next half an hour. I wanted to make sure we had time that you guys can all talk to each other and share thoughts, comments. The patios out here, I'm assuming there'll still be more food and drinks out in the patio. So enjoy for the next half an hour. Thanks.